August 2017 Common Core Regents final exam. Question 1 is a cross-section problem. What it is we've got to remember what cross-section is. Think slice the 3D object in half, and then what two-dimensional shape will be exposed. Okay. Now, what we want to make sure is that we do not have a figure, a 3D figure, that can produce a cross-section that's a triangle. Cone can. Okay. So if we draw a cone, if we were to slice, let's say right down there, right down the middle, okay, the shape that we would produce is this right here. Okay, so that would be a triangle. A pyramid, same thing. Go through the point of the pyramid, right through the base. It's going to be a triangle. Rectangular prism, we could hit, let's see, we could definitely hit a rectangular prism. If we came through, let's see, through one of the corners and think slice that way, we could produce a triangle that way. So we could get all these, triangle out all these. We cannot out of this. What we'd end up with is, in some instances, we'd end up with basically a parabola as our cut. So if we went through this way, right, it almost looks like we'd be making a triangle, but it's not going to be. What we'd end up having is kind of this shape. Okay, so that's it. Number 2. Oops, sorry. Number 2, which transformation will the triangles not be congruent? The only one that's going to change the size would be a dilation or a stretch. Now we have a couple options here. A dilation scale factor of 1 doesn't change the size. A scale factor of 3/2 does. So that's the one we want there. Okay, vertices of RSTV. It is a square, and we want the perimeter. Now, what I would do on this is I would graph it, calculate the length of just one side. Now, I would graph it on the scrap graph paper. So I'll go get some scrap graph and be right back. So I went and grabbed some scrap graph paper, just snipped that quick. Get used to using this for part 1s. It'll be helpful. This is R, this is S, T, and V. It says it's a square already, so I actually don't have to calculate the length of all 4 sides. What I'm going to do is just calculate the length of RS. Okay, so what it's going to be is 4 and 2. Okay, so I'll pull that out. So up and down for RS is 4 for the change in Y, 2 for the change in X. And what I'm going to do is Pythagorean Theorem. Okay, so that's going to be 20. So square root of 20 is RS's length. Now, we need 4 of those. So the perimeter of the entire square would be 4 of those square roots of 20. All right, this one is, there is a theorem that's a shortcut for this. When chords are parallel, the arcs in between them are congruent. So, a couple ideas. All the way from here to here is 180. Now, from here to here is 130, leaving us with 50 that we should split in half. Now, if you didn't learn that theorem, there is a way around that. Okay? So when we have parallel chords, what we have is a situation where alternate interior angles are congruent. Now, these are both inscribed angles that are congruent. What they must open up to, the arcs they must open up to, see this one opens up here, that's got to be congruent to that one, because the inscribed angles. So just for instance, say we know this angle is 25. Okay, we don't know the other one. then that arc across from it is 50. Okay, alternate interior angles would give us 25 there. Double it to get the arc across from it, 50. That doesn't, oh, wait a minute. Yeah. Hang on one second. That has to, okay. So, bad example. Let's do that again. Okay, let's say the arcs, because the arcs are 25 each, let's say the arc is 25. That's going to make this angle that it comes from 12.5 degrees. So then that would be 12.5 degrees, so the arc would be 25. Okay, we knew this was 130. Now all three of these add up to 180. Everything works. Okay, so that's what we're looking at there. Sorry about that second one. Number 5. Let's see. So let's put these on here. 6.6, 3.4, 4.2. Okay, they're giving us all the sides. AB parallel. Okay, these triangles are going to be similar. All right, by alternate interior angles and vertical angles. All right, let's see. Length of AC, that's going to be X. And, okay, they do give us BC is 5.25. So, let's make sure that we identify what the corresponding sides are. Okay, so I'll highlight. Hopefully you guys do this too. 5.25 corresponds with a 4.2. Okay, and X corresponds with the 6.6. Okay, those are corresponding sides. So what I want to do is put a proportion together with 5.25 over 4.2, X over 6.6, and then I want to cross multiply. 4.2x will equal, let's see, 34.65 divided by 4.2. X is equal to 8.25. So there it is. All right, last one for this video. Okay, map onto itself. We need to know is symmetry. All right, which transformation would not map onto itself? So you should just test them all here. If we reflect over the x-axis, that would map it onto itself. Now, some of the confusion with this, mapping onto itself. We're not talking about congruence here. Everything here is congruence. What we're talking about is not creating a new outline for the figure. What I mean, in other words, is let's say this is A, B, C, D. And there's other points on this as well. That's another point we could call E. Basically, what I'm saying is when it maps onto itself, every point, say A, would map onto another point that already exists on the figure. That's mapping onto itself. Now, A doesn't land back here necessarily. It lands somewhere on the figure. So no new points are created. Now, a reflection over the x-axis will do that. A will go to D, D will go to A. Okay, E would go right here, and vice versa. So a reflection over the x-axis will map that figure onto itself again. A reflection over the line x equals 4, that's a vertical line, right there. You can see that those will all map onto each other. You know, this point here would map over there. Every point has a match on the other side. There's no new points created. That'll work. Okay, rotation of 180 about the origin does create a congruent figure. However, this point A will be down here, A prime. So basically what we're going to end up with is a new figure. Right there. Okay, B prime would land there. D prime would land there. And C prime would land there if we did this. So that is the one that will not map onto itself. It created a new figure. All right, so that's the first 6 part 1s from this exam. And tune in for the next ones.